What's up everybody? In this video, we are going to learn how to control motors using an Arduino. We will be using the motor driver circuit we built in a previous video. By the end of this video, we will write code that will have both motors moving forward. Start off by logging into Tinkercad using your course username. Select Circuits in the menu under your designs. You will see our motor driver circuit that we made in an earlier video. Hover over the circuit and click on the Tinker This in the top left-hand corner. Since we built the circuit in a previous video, we're going to add code. Click on the Code tab and ensure the text drop-down is selected. Fill out the information in the header of our code. Update the program name and description. The program name is Motor Driver, and the description is a sketch where we will control motors using a motor driver chip. Declare the variables. Remember that each motor has 3 pins. One is used for an analog output to control the speed, and 2 are used for a digital output to control direction. Type int left speed equals 3, semicolon, and int right speed equals 6, semicolon. These variables are the analog outputs. They are the Arduino pins connected to the enable pins on the motor driver. In my circuit, I color-coded these with turquoise wire. Next, type int left A equals 4, semicolon, then int left B equals 5, semicolon, then int right A equals 7, semicolon, and int right B equals 8, semicolon. These are the digital output pins on the Arduino. In my circuit, I color-coded these green and orange. Next, we will tell the Arduino each of the pins is an output. We have 6 pins. But we could write pin mode statements for each pin. Let's look at how we could use a loop and write fewer lines of code. Loops are great for repetitive tasks. In the setup function, type for, open bracket, int x equals 3, semicolon. X is less than or equal to 8, semicolon, x plus plus, end bracket, open curly brace, close curly brace. So what's going on here? We initiate a for loop, and inside the brackets, the first parameter is the initialization. This happens first and only one time. In our loop, we create a variable x and give it a value equal to the first pin, so pin 3. Next is the condition. Each iteration through the loop will check the condition and will only execute if it is true. In our loop, it will check to see if the value of x is less than or equal to 8. 8 is the last pin we are using. Last is the increment. This is executed each time through the loop when the condition is true. So each time it will add 1 to x. Now we can add code inside the loop to tell the Arduino that each pin will be an output. Type pin mode, open bracket, x, comma, output, end bracket, semicolon. Also add a serial.println open bracket, x, close bracket, semicolon. We'll use this to double check that the loop is working properly. Each iteration through the loop will update the pin number in the pin mode declaration. Click Start Simulation and open the serial monitor. You should see the numbers 3 through 8 showing up in the monitor. Awesome! We used a loop to perform a repetitive task. This is something computers are really good at, iterating through data and tasks that can be easily replicated. We can remove the serial.println statement, as we only needed it to confirm the loop was working. This is a good time to talk about creating a practice when writing and executing code. From my experience learning how to code, most of my time has been spent trying to figure out why something doesn't work. This is really frustrating and can be difficult when you have a large block of code. A methodology I recommend is to constantly check that your code is doing what you think it should as you write it. This is where the serial monitor is useful. We can use it to check values and ensure they are correct before moving to the next step in our code. Okay, let's get moving, literally. Now we will add code to our loop to make our motors move. Remember, we have analog and digital outputs. First, we will control the speed of the motors. This is an analog output. Type analog right, open bracket, left speed, comma, 255, close bracket, semicolon. Then analog right, open bracket, right speed, comma, 255, close bracket, semicolon. Remember, the analog value can be between 0 and 255, 0 being off and 255 being full power. Next, the digital output for each motor. Type digital right, open bracket, left A, comma, high, close bracket, semicolon. Then digital right, open bracket, left B, comma, low, close bracket, semicolon. Then digital right, open bracket, right A, comma, high, close bracket, semicolon. And last, digital right, open bracket, right B, comma, low, close bracket, semicolon. Remember when we tested the motors, to move in a direction, we need to send a high and low digital output for the motor to move. Okay, time for the big reveal. Click Start Simulation, and you should see both motors moving. Yay! Okay, so there is something very anticlimactic about doing this virtually. When you do this with your Arduino and wheels, when it moves, it is pretty cool. Remember, lift your robot wheels off the ground before you upload the sketch and test it. This part of the video is only if both motors are not moving forward on your robot. If you followed along and your motors are moving in opposite directions, we can adjust the code to fix it. When I click Start Simulation, you will notice one motor has a negative in front of the speed. This means it's moving backwards. How do we fix it? Go up to your variables section and change the pins for either left or right A and B. When you build your robot, you may need to adjust your code to ensure both motors are moving forward. This is something you will need to test on your own. At the end of this video, you should have a better understanding of a for loop, how to control motors with an Arduino, and your robot should move forward.